All right, in this video, we're going over two-variable inequalities. All right, here's your vocab. First word, linear inequality. Basically, an inequality with two variables. Second one, boundary, a line that bounds an inequality. And I got a picture down here. When you solve your inequality, you're going to have a line and you're going to end up graphing a line. That line that you graph is your boundary line. Okay, that's the line that bounds the inequality. Half plane, the two planes separated by the boundary line. When you draw that line in, the part below it and the part above it are both called half planes, because just imagine you're splitting the entire coordinate plane in half. So you have two halves. And test point, a point not on the boundary. So for this, a test point might be, say, 0, 0, because it's not on the boundary. Same thing over here. You could still use the point 0, 0 because it's not on the boundary. But you could pick any point. You could pick this one. You could pick this one. Same thing over here. You could pick this one. You could pick this one. As long as it's not on the boundary, it's a test point. All right? We'll go over more of what that is in a minute. All right, so let's look at these. And we're going to end up graphing some of these. So I got the graph paper here. All right, let's look at the inequality y is greater than 3x minus 1. All right, there's no solving for this. Okay, if it's not in the form of y is greater than or some inequality sign and then the rest of your inequality, you need to make sure you get y by itself like we've done before. You always make sure y is by itself. Now, what we're going to do is we're going to graph this just like a line, like it's y equals 3x minus 1. All right, so we're going to go down 1. So here's our y-intercept. And then our slope is 3, so we're going to go up 3, 1, 2, 3, over 1. And then let's go down 3, 1, 2, 3, over 1. So we have a few points there. Now, since this is greater than, there's no equal to bar. What we're going to do, I hope this works out well. What we're going to do is, instead of drawing a solid line, we're going to draw a dashed line. Just like that. And the reason it's dashed and not solid is because this is not greater than or equal to. So the points on this line do not solve this equation because there's no equal to bar. So the points on this line, since they don't solve it, we represent that with a dashed line. Okay? Now your test point that I was talking about earlier. As you can see here, our line does not go through the origin 0, 0. So we can use the origin as a test point. So 0 greater than or equal to 3 times 0 minus 1. So that's 0 is greater than negative 1. Is that true? Yes, it is. So now, since we know that the point 0, 0 satisfies our inequality, what we're going to do is we're going to shade everything on that side of our line. Hopefully you can see the yellow. If not, at least you can see what I'm doing. So, since the point 0, 0 solved our inequality, we're going to shade everything on that side of the line we drew earlier, of the boundary, because remember, that's the boundary. Now, there's a little shortcut to this. You see how y is greater than the inequality? Well, if y is greater, you shade above the line. So see how we kind of shaded above it? If this is less than, you shade below it. All right? Greater, you shade above. Less than, you shade below. If you can't figure out which is which, just pick a test point. Remember, your test point cannot be on your boundary. Pick a test point. I usually pick 0, 0. Because normally 0, 0 is not on your boundary. If it is, pick something else easy, like say 1, 1. All right? Don't pick some complicated like -2, -4. Pick an easy point. Pick a point that you can easily plug in and solve for. All right? Don't pick something crazy and complicated. All right? All right, now let's look at absolute value inequalities. So let's look at 1 minus y less than the absolute value of x plus 2. First thing we need to do, we need to get y by itself. So minus 1, negative y less than the absolute value of x plus 2 minus 1. Multiply everything by negative 1 to get rid of the negative over here. So y, we need to flip this over. Negative x plus 2 plus 1. All right, so since it's negative, we know it's going to be upside down because it reflects over the x-axis. And we also know that it's going to shift 2 to the left and 1 up. So what we can do is we can go ahead and plot our vertex. So 1, 2, 1. We know it's going to be there. Since the absolute value of a is 1, because remember there's an imaginary 1 right there, we know our slope, we know it's not going to be stretched or compressed, so we know our slope is 1. So we know we're going to go through this point and this point. We're going to go through this point and this point. All right, so now, again, since there's no equal to bar, don't draw a solid line. You need to draw a dashed line. Do the same thing for both sides of the absolute value. So you have your absolute value v. Now, y is greater than. So that means we're going to shade everything above our absolute value. So that means that all of this here, everything that is above that line, is going to get shaded. I really hope you can see that. I prefer not to use a darker color, but so everything above that line is going to be shaded. And again, since there's no equal to bar, this is going to be dashed. So as you can see, this is pretty much like you just basically graph the equation. You solve it for y, graph the equation, and before you draw your lines in, make sure if you have an equal to bar, it's a solid line just like a normal graph. If there's no equal to bar, it's a dashed line. All right. Now, just to make sure we shaded the right side, let's pull a test point. Let's do 0, 0. So 0 greater than negative 0 plus 2 plus 1. So 0 greater than, this is 2, so this is negative 2 plus 1. 0, negative 2 plus 1 is negative 1. Is 0 greater than negative 1? Yes, it is. So that confirms that we shaded the correct side. All right. So I was trying to keep this video shorter. I know you can solve two-variable equations, and we solve two-variable inequalities the exact same way, but just remember, when you're dealing with an inequality, if you multiply or divide by a negative number, like we did here, you have to switch your sign. If it's less than, it's got to go to greater than. If it's greater than, it's got to go to less than. And if it has an equal to bar, that comes along for the right as well. But remember, if it's just greater than or equal to, you're going to have a dashed line. If it's greater than or less than, dashed line. If it's greater than or equal to or less than or equal to, it's going to be a solid line. Okay? So like I said, I was trying to keep this video shorter. So that's your video. Make sure you understand how to solve two-variable inequalities. They solve just like two-variable equations. You just have to remember that when you multiply or divide a negative across the sign, it flips. And when you graph them, if you don't have an equal to bar, it's dashed. If you have an equal to bar, it's solid. That's pretty much it. All right, make sure you understand the concepts in this video. See you tomorrow.